Alright, hello everyone. So here we have another differential equation and we want to use separation of variables. So it's easy to separate. We can just take the square root y into the left hand side and divide by square root y. Take dx to the right. So here we got the separation. Now let's integrate. To integrate the left hand side easily, let's rewrite it as, so now here's the thing. Square root y means y to the power half. Okay, let's first write it like that. Then let me continue here. Now to write y to the half, let's write it as y to the negative half. Let's take it to the numerator, okay, to make our integration easier. Now we can integrate from here. So if you integrate y to the negative half, you get y to the negative half plus 1, divide by negative half plus 1. And if you integrate 7x, you get 7x square over 2 and plus c, the constant of integration. Let's call it c1. Now negative half plus 1 is y half. Here negative half plus 1 is half. 7x square over 2 plus c1. So from here on, it's all about simplification. So if you divide by half, dividing by half is same as multiplying by 2, right? You take the reciprocal multiplication. So it's 2y half 7x square over 2 plus c1. Now to write the explicit solution, we can divide the right hand side by 2. So each term dividing by 2, you get 7x square over 4 plus c1 over 2. Let's call it c2. c1 over 2 is c1, another arbitrary constant. Now to find y, let's take square, right? We need to get rid of half. So this y to the half means square root of y. So let's take the square of the right hand side and that gives you the explicit solution for the differential equation. Okay. Alright, so that's the solution. Okay, so let's solve another problem in this video since it's a short video. How about if you have a differential equation y prime is equal to e to the 3x plus 2y. Now this is a tricky one. First of all, what does that y prime means? It means dy over dx, right? Okay, don't get confused about that. Now how do we separate here? Well, the addition here on the power means multiplication on the base, right? So it's e to the 3x times e to the 2y. So we can use some help from algebra. Now we can simply separate. We can take e to the 2y to the left and dx to the right, and we have to integrate. Now here we can write the left hand side integral as e to the negative 2y. So I took it to the numerator, then the power becomes negative, right? If you switch it from numerator to denominator or denominator to numerator, the sign switch. Now if you integrate e to the 2y, e to the negative 2y with respect to y, it's e to the negative 2y divide by negative 2. So that's coming from basic integration, okay? So e to the 3x, if you integrate, you get e to the 3x over 3 plus constant of integration c1. So be careful with the integration, okay? Review your basic integration knowledge. Now to get the explicit solution, let's multiply the right hand side by negative 2. So it's e to the negative 2y. Let's see here, negative 2 e to the 3x over 3. Let's call it plus c2 here because negative 2 c1. Let's call it c2, an arbitrary constant. Okay. All right, let me find some space. E to the negative 2y is equal to negative 2 e to the 3x over 3 plus c2. Perfect. Now, how can we make y subject? How can we write the explicit solution here? Because y is in the power of e. Well, we can take the natural log of both sides. We can use little help from algebra. Let's see what happens. Now, using the logarithmic property, we can write this expression as negative 2y natural log e. We can write it in front of natural log. On the right hand side, we don't need to make any difference, okay? We only care about the left hand side, right? We want to make y subject. Natural log e is 1. That's a universal rule, okay? Universal result that you should know. And to find the explicit solution for y, it's just you need to divide by negative 2. Okay, so here we need to take the absolute value because we don't know whether it's positive or negative. Okay, so let's write the absolute value. So I forgot about that. Sorry about that. So y is actually natural log absolute value negative 2 e to the 3x over 3 plus c2 divide by negative 2. So that's the explicit solution. Okay. All right. So some algebra tricks in this second problem, right? Okay. Thank you very much. All right, hello everyone. So here's another different looking differential equation. Now it's not exactly in the format where dy is over dx is equal to everything else, right? But we can certainly come up with that formation. How do we accomplish that? Well, let's do some algebra. Let's take this term to the right hand side. So y dy is equal to minus x plus 1 dx. Now you don't think about this. You don't need to write dy over dx because look at this expression. It's already separated. It's in the separated form. Y terms are already isolated in the left hand side. X terms are already isolated in the right hand side. This is your separation. You can integrate from here. Okay. But if you're interested in writing it in dy over dx term, it's just bring that y to the right hand side and minus x plus 1 over y. Okay, so this differential equation was rewritten in a different format like that. Okay. All right, now let's integrate. We don't need to worry about this. Let's integrate. So if you integrate y, it's y square over 2. Okay, so it's simple. Let's distribute this negative, okay, to make sure we don't do any algebraical mistake in the integration. Y square over 2, and if you integrate minus x, it's minus x square over 2. If you integrate minus 1, it's minus x. Constant of integration, c1, an arbitrary constant. Now let's say you want to find the explicit solution, so let's get rid of this 2. Let's take that 2 to the right hand side by multiplication. So let's multiply each term by 2, so it's going to be minus x square. This 2 and that multiplication 2 cancel out. This becomes minus 2x. 2c1, let's call it c2. 2c1 is c2, another arbitrary constant. Now if you want to find y, just take the square root. So it's square root of minus x square minus 2x plus c2 plus so minus. Okay. All right. This is a simple problem, right? It was easier than what I thought. Okay, so that's the solution. That's it, the explicit solution for the differential equation.